Hello, I'm Joshua Wilson, and today I'll be discussing magnetic resonance imaging, which is more commonly known as an MRI. As shown in the slide, MRIs are commonly used to treat patients by allowing medical professionals to view organs and structures within the body. This non-invasive treatment is used 40 million times each year in the United States, and has been used to help cure millions of patients. Originally, scientists studied nuclear magnetic resonance, where the nucleus of atoms in a magnetic field would resonate after another external field forced their axes to rotate. This allowed them to examine intricate chemical processes. Later, spectroscopy, which is now referred to as MRI, allowed scientists to determine the atomic makeup of physical, chemical, and biological matter. After this development, three scientists began a race to develop a reliable method for creating images from magnetic resonance. This resulted in the first whole-body human scanner in May of 1977. Now, MRIs are extremely prevalent in the medical industry to help treat patients with complex issues. Without this necessary tool, caregivers would not be able to provide proper treatment. To understand the overview of how an MRI operates, we first need to introduce two important concepts: how protons align in a magnetic field and how radio frequency, or RF pulses, disturb protons. On the left side of the screen, we will see there are water molecules. These molecules are extremely prevalent in the human body. A hydrogen atom is a part of the composition of a water molecule. The hydrogen atom has a nucleus that is composed of a single proton. These protons spin on their axis and act as a miniature magnet. When an external magnetic field is placed on the spinning proton, it will align along the magnetic field. Once aligned with the magnetic field, the proton will continue spinning on its new axis at a particular frequency. On the right side of the screen, we will see a short RF pulse followed by a resonance. The RF pulse can be used to disturb proton alignment if it has the same frequency as the spinning of the proton on its axis. Once the pulse is applied, the proton will have a period of time where it is trying to realign itself once it is pushed off of its alignment. This period of realignment can be measured by external sensors. For such an incredible technology, the basic operation is extremely easy to understand. The body has natural magnetic properties due to the presence of hydrogen nucleuses, which is a single proton, in water and fat. Normally, these protons are spinning on its axis and are randomly aligned. When a strong magnetic field is placed over the protons, they all line up along the magnetic field. Next, a radio wave is added and deflects the alignment of the protons along the magnetic field. The radio wave is then cut off, and the protons realign with the magnetic field. The energy released by the protons during this process, and the time taken to realign, allows for complex imaging to be created and determine the material in the body. The radio frequency waves used in MRIs are electromagnetic fields that store energy, and will be absorbed by the protons in the water molecules of the body. The field can move as a plane wave in air, with the direction of propagation, electric field, and magnetic field perpendicular to each other. Once this field interacts with the surface, such as the body, it will have a reflected and transmitted wave at the surface. The transmitted waves are then absorbed by the protons aligned in the magnetic field. Another important class concept occurs when a signal is received after the introduction of the RF wave. The signal recorded by the sensors of the MRI are also electromagnetic fields, which produces an electric current in the device that will be used to transduce into digital values. The electric current produced in the device is based upon the principles of Lenz's law, which states that the generated current is always in the direction that opposes the change of magnetic flux. Thank you for listening to my presentation on magnetic resonance imaging, or MRI. Originally, this technology was used for complex chemistry experiments, but is now present in most modern hospitals. Due to the alignment of protons within the water molecules in a magnetic field, we can force these particles out of alignment from radio frequency pulse. The release of energy that produces a current described by Lenz's law can then be digitized and converted into imaging. From our course, we can find that RF wave is a planar wave traveling in air, and once interacts with the surface of the body, produces an incident, reflected, and transmitted wave. Another core course concept was the use of Lenz's law to produce a current from a change in magnetic flux.